Alright, so we're going to take a look today at some review. Our test grades were not great, and so we're going to take a look at some review of everything we've done in this chapter. I'm going to give you guys a chance to review today and restart your test now, or maybe go back next time and restart it. So in this review, I'm not going to go very slow. If you need to pause something, rewind it, you can. And if you need to take notes if you haven't taken notes up until this point. So this is the test review sheet that I gave you a couple of classes ago before Thanksgiving break. So what we're going to take a look at first is we're going to take a look at how do you determine if something is linear or not linear. So the first thing I had you answer on the test and on this review was looking at this and placing a check, in the correct column for linear or not linear. For a linear equation, it has to be variables that are raised to the first power. You cannot have a variable that is inside a radical. You cannot have a variable inside an absolute value. And you cannot have a variable in the denominator of a fraction. So notice on this first one, you're raised to the third power, not linear. The second one, first power, linear. The third one, first power, linear. But then you get into number 4, you've got this radical, and I apologize for it not being all the way across, but you have a radical, it's a square root of x, that is not linear. Number 5, you have the absolute value of x minus 4, not linear. Number 6, you have the x in the denominator of the fraction, not linear. You should be able to look at it because it should have x and the y raised to the first power, and it does not have a variable in a radical. It does not have a variable in the absolute value. It does not have a variable in the denominator of a fraction. That's how you tell if something's linear or not linear, by looking at the function. The second section, we had some tables to decide if they are not linear. Remember, we also talked about this a little earlier in the year where we said if something's a function or not. Remember, a function has each input has one output. That's not the same for linear versus non-linear. So, what you're trying to decide is, does this represent a linear function? Meaning, in the table, is there slope? Notice this one is going down 2, down 2, down 2, down 2. This one over here, the x value is going over 1, over 1, over 1, over 1. That means this graph is going down 2 over 1. That's my rise over run the whole time. This is linear. Notice this one over here, it goes down 3, down 1, down, oh no, it goes up by 1, up by 3. This over here is going over 1, over 1, over 1, over 1. That is not the same thing every single time. So it is not linear. It has to be the same pattern the whole time to be linear. Next, you have a problem where you are checking solutions. I am not going to go through this problem because you should be able to check an answer by taking 8, plugging it in for x. Taking -3, plugging it in for y, because that is my x, that is my y value, and you plug them in to see if it equals 0. If it works, it is a solution. If it doesn't work, it's not a solution. On the next page, the first thing we have here is graphing this by solving for y. Solving for y means get the y by itself. That means I'm going to take the 12x and I'm going to add 12x to this side. I'm going to add 12x to this side. Pardon me for not having enough room here. But when I add 12x, negative 12x and positive 12x cancels out. 24 plus 12x is 24 plus 12x. You cannot really add those together. Then we divide by 6 on both sides to get y equals, which is what we were asked to do. What is 24 divided by 6? 4. What is 12 divided by 6? 2. 4 plus 2x, or you could switch it around and put 2x plus 4, is what you are going to actually plug in your x values to find your y values. Typically, we do plug in negative 2, negative 1, 0, 1, and 2. 2x plus 4, or 4 plus 2x, is what I plug it into. This is just calculator work. 2 times negative 2 is negative 4. Negative 4 plus 4 is 0. And you keep going down the list. 2 times negative 1 is negative 2. Negative 2 plus 4 is 2. But I can tell by looking at this, it's going to be linear. So there's also a shortcut. You know, the next one's going to be 4. The next one's going to be 6. The next one's going to be 8. Because that is what linear equations do. They have the same pattern. When you go to graph your equation, you can put your axes wherever you want. I'm just going to put mine sort of random here. I'm going to put one right here in the middle of these two on that vertical axis there. And I'm going to put another one right here. It does not matter as long as you put your axes, the middle point is 0, 0. Now I apologize, this one's going to be kind of off a little bit because of this being on a different program. Slide that over. Negative 2, 0. The first point right here, negative 2 and 0 for y. You go left 2 and stay at 0. Negative 1 and 2, negative 1 and 2, left 1 and up 2. And you have 0 and 4, 1 and 6, 2 and 8. And then you connect your dots with a line. This one's probably going to be a little off here, but I will go ahead and try. We'll see what happens once we remove. Look at there, it worked. The next question says, is 1, 2 a solution? 1, 2 is right here. Is that a solution? No, it is not on the line. The points on the line are solutions to the equation. The next problem, two problems actually, ask you to find the X-intercept and the Y-intercept and graph the equation. How do you find the X-intercept? To find the X-intercept, you literally let y equal 0, meaning you plug in 0 where y is. That gives me 7x equals 35. Because what is 10 times 0? Nothing. Then you divide by 7 on both sides. When you divide by 7 on both sides, what is 35 divided by 7 going to give you for x? 5. That's my X-intercept. But I also told you in class I was going to be a jerk math teacher. You gotta write that as a point. 5 for x, 0 for y. 5 for x, 0 for y. How do you find your y-intercept? To find the y-intercept, we let x equal 0. So we plug in 0 where the x is. Now what is 7 times 0? Nothing. That leaves me with 10y equals 35. Then you divide by 10 on both sides, and that gives me y equals 3.5 as a decimal. That would be 7 over 2 as a fraction. The reason I know that is because I could take out my calculator and do 35 divided by 10. You guys just thought it messed up in class, huh? 35 divided by 10. Press enter. Math, enter, enter. Changes it back to a fraction of 7 halves. Now, again, I write this as a point. This time 0 for x, because that's what I plugged in. 3.5 for y, because that's what I got. Then, you could graph those two. Again, I'll do my best here. Probably going to be a little off. Just a little bit. It's okay. 5, 0 is 5 spaces for x, 0 for y. 0, 3.5 is in the middle. It's 0 for x, 3.5 for y. If you connect those two dots together, you have your line. Number 14 and 15, you could choose whatever method you want to graph. If you want to do one of the methods that we just did, solving for y, or using the intercepts, you could. But you could also just take y equals 2x plus 4 and use a shortcut that I gave you. Remember, we talked about y equals mx plus b, where the m is the slope, and the b is the y-intercept. So what I told you could do is if you see an equation that fits that format, notice in number 15 you would actually have to solve it first to get it into that format. But if it fits that format, all you have to do is, wow, that was really pretty, wasn't it? We'll be alright, right? Slide over a little bit. Is begin at this number and then move with this number. So where do I begin? At -4. So I go down 4, put a point. My slope, my m, is 2, which is the same thing as 2 over 1. So my rise over run tells me to go from my beginning point up to over 1, up to over 1, up to over 1. Guys, that's how slope works. It goes all the way across the graph, not just some parts of it. Connect the dots, you got a line. And every point on this line is a solution. Now you could do the same thing if you wanted to with number 15. You could also do like we did with number 13. and number 10. It's up to you. Skip it on down. We got to finding the slope. There is a formula that I gave you for finding the slope. The slope formula is y2 minus y1 over x2 minus x1. So you take your points, you do 35 minus 3 over negative 16 minus 16. Y2 minus y1 over x2 minus x1. As these are points, slope is a fraction, rise over run. What's 35 minus 3? That's 32. You need a calculator? Use a calculator. What's negative 16 minus 16? Negative 32. If you don't believe me, take out the calculator. What is 32 divided by negative 32? Negative 1. There's my slope. On this one, you had 4 minus 4 over 2 minus 0. 4 minus 4 is 0. 2 minus 0 is 2. That's 0 over 2, which is 0. This one is a horizontal line. If you look at the points, the y values are the same. That would mean that my y values are 4 for both of them. My y values will be 4 the whole time, which makes a horizontal line. Number 18. Remember what I just talked about on the previous page. Y equals mx plus b. The m is the slope. Well, guys, guess what? That means my slope is 7. Done with the problem. Number 19. My m is 10. My b is nothing. There's not a b there. Done with the problem. My m is 1/2. My b is 6. Done with the problem. You should not miss those. Number 25. 25 deals with finding the rate of change. Guess what, guys? Rate of change is still basically the same thing as the slope. Now, I did give you a little hint here. I told you to use years after 1960 and price of a car as your X value and your Y value. That'll probably help you a little bit. The first point was 1960. That means the years after 1960 would be nothing. The price here was 85 cents. Now, I don't know why I put car here on this one. That was a typo. In 1995, that's 35 years after 1960. 60 to 95 is 35 years. The price was $4.50 for the movie ticket. If you do y2 minus y1 over x2 minus x1, you'll find your slope, but you'll also be able to find your rate of change. Notice that even though the points are written like this, these are my x's, these are my y's. Pay attention and do change in y over change in x. If you do this, you take out your handy dandy calculator. 450, 4.50 minus 0.85 or 85 cents, you get 3.65. That means I'm going to have 3.65 on the top. On the bottom, 35 minus 0 is 35. That's not going to tell me how much the movie changes per year. I still have to go back to my calculator and do 3.65 divided by 35. Press enter. 0.10. Now if I needed rise over run, I'd hit math, enter, enter. But that's ugly. That's 73 over 700. I don't need that rise over run because I'm talking about movie ticket price per year. decimal is more appropriate on this one, and it's 0.10, which is 10 cents per year. So approximately 10 cents per year. If you don't put your units, yes, you're partially wrong still. Number 26 was graphing two of the easiest lines you will ever graph. These are y equals 1 and x equals -2. If it only has y equals 1, that is a horizontal line. All you have to be able to do is count up to 1 and then draw a horizontal line at 1. So you go up to 1. Sorry guys. And then graph the horizontal line at 1. So I go up to 1, and graph a horizontal line at 1. X equals -2 is a vertical line, but it's at -2. So you go over to -2 and you graph your horizontal line at -2. Notice I had to kind of adjust because I know this thing's a little bit off, but it's -2 the whole time. Alright. This thing's not going to like me right now. Alright, let's see what we can do here. I apologize. This thing's freezing up on me a little bit here. I'm going to try something a little different here. Alright, so maybe we got it fixed. Alright, good. Now there was a lot of portions of this last part of this review where I went through some of the same things that you had in the previous part. I did ask you to know what slope-intercept form was. Slope-intercept form is that y equals mx plus b. Slope formula, I asked you to know that. y2 minus y1 over x2 minus x1. Also, went back and reviewed a little bit of the things we talked about before. Slope-intercept form. Remember mx plus b. M is 2, b is -5, just by looking at mx plus b. Then I could graph it by beginning at -5, and then going up 2 over 1, up 2 over 1. That was my slope. Here's my line. Done. Number 3, yes, I would have to add 3x on this side. Add 3x on this side to get 2y. 6 plus 3x, because you can't really add those together. Divide by 2, divide by 2. You get y equals 6 divided by 2, 3. 3 divided by 2 is 3 halves. So that means my m is 3 halves. How do I know? Because it's mx plus b, 3. There's my b. So I begin at 3, and then I move up 3 over 2. You can also go backwards the slope. You can go down 3 and to the left 2. But it's still going to be positive 3 halves because it goes up 3 over 2 across the graph. Then we had these. This gave a lot of people some issues, so I want to make sure I talk about this. Follow the directions, guys. Don't overcomplicate it. It says the starting distance was 7, so go up to 7, put a point. How'd you know that was where you start? Because the time is down here at the bottom, that means 0 seconds. Starting at 7. Section A is slope of -3, down 3 feet, over 1 second, 3 feet per second, down 3, over 1 is my slope, for 2 seconds. So you go down 3 over 1. That's 1 second. Down 3 over 1. That is 2 seconds. Section B, 0 feet per second for 4 seconds. That doesn't mean go to 0. That means the slope is 0, which means flat for 4 seconds. 1, 2, 3, 4, 0 slope. Section C, M, or 2/3 here, my slope is 2/3. That means up to over 3. But it says for 3 seconds. If you go up 1, 2, and you go over 1, 2, 3, that is up to over 3, but that's also 3 seconds from 6 to 9. Then it says 5 feet per second for 2 seconds. Up 1, 2, 3, 4, 5, over 1. But it said do it for 2 seconds. Up 1, up 2, up 3, up 4, up 5, over 1. That is for 2 seconds, from 9 to 11. That means here is where I end. What's the distance? 13 feet. What's the fastest section? The last section we just did, 5 feet per second. That is section D. What's the slowest section? 0. When you are not moving in section B. Section A is here, section B is here, C is here, and D is here. D's the steepest. That's the fastest. B's the flat one, 0. That's not the steepest. It's the slowest. The last little part down here is also kind of leading you into some things we're going to talk about even in the next chapter. It says here's my slope, here's my B, my y-intercept. What's the equation? Y equals mx plus b. You didn't do plus, you did minus. That's because it's a -2 for b. Y equals 3 over 7x minus 7. Here's my y-intercept. Here's my slope. Y equals 1/2 x plus 3. My m, my b. Just got to plug them in. You just got to know the slope-intercept form. Finally, there's a few questions. We'll take a look here at this last little section here because it ties close back to those as well. Just answering some questions about a graph. First of all, what is the slope? Notice it goes through this point and it goes through this point. Those are the ones I know for sure. That is down Now if you count it, 1, 2, 3, 4, 5, 6, 7, that's down 7. But look at what it's actually counting by. It's down 70. Over 1, 2, 3, 4, right? No. It's going over 5, 10, 15, 20. That is negative 70 over 20. Let's talk about what you would do in the calculator. If you took negative 70 divided by 20, that would give you a decimal answer. In real life, that may be useful to have that decimal answer. For slope, which is still real life, but you need the rise over run, you have to hit math, enter, enter. That's negative 7 halves. So my slope reduces to negative 7 over 2. There's my slope. That means really what Tricia is doing here, she's losing 7 pounds every 2 weeks. Or, what that decimal was in the calculator, negative 3.5 pounds per week. What is the B? The B is the Y-intercept. Here it is. The Y-intercept is here at 70. That's the B. Now, technically that is 0, 70, but I would have let you even slide on that one if you accidentally just put 70. But it is a point on the graph, the Y-intercept. What does it mean? It means pounds to go. That means Tricia has 70 pounds to lose. Guys, that's just being able to read what the graph is talking about. You have got to be able to do that for life outside of school, not just Mr. Harrison's class. Write the equation of this line in slope-intercept form. Y equals mx plus b, so y equals m is negative 7 halves, x plus b is plus 70. There's my equation. Now, I'll also ask you about the x-intercept a little bit over here. Here's the x-intercept. It's at 20, 0, because what does that mean? That means 20 weeks, and Tricia loses all her weight. She loses all the weight. Guys, you've got to be able to read and interpret what math means. Not just be working with numbers. You got to be able to read it and interpret it as well. There's real life implications to these things we call the x-intercepts and the y-intercepts. They're important to us. The slope is important to us, telling us how much weight she's losing each week. Rates are things you will see all throughout your life. Slope is critical. So, I hope you've taken the time to review this whole video. If you need to go back and watch parts of it again. If you need to practice things again before you watch me do them, go practice them before I do them. See if you did it right. Take good notes. Go back and write down notes, because now you're going to have to go through and redo your tests. You need to do better.